Acid rain, the crisis that quietly faded. In the mid-20th century, strange things started happening in the northeastern United States and parts of Canada. Lakes that once teemed with life suddenly became barren. Entire forests turned yellow and died. Buildings and monuments were corroding faster than ever before. Scientists, including American ecologist Gene Likens and biologist Herbert Borman, were among the first to connect the dots. In the early 1960s, their research in New Hampshire revealed that rainfall had become unusually acidic, sometimes with a pH as low as 4.1, comparable to tomato juice. The culprit was air pollution. Emissions from coal-burning power plants and factories released sulfur dioxide and nitrogen oxides into the atmosphere. These gases reacted with water vapor to form sulfuric and nitric acids, which then fell to the earth as acid rain. The damage was widespread. Lakes lost aquatic life. Soils were stripped of essential nutrients. Iconic structures like the Statue of Liberty were literally being eaten away. After decades of mounting evidence and public pressure, the United States passed the Clean Air Act amendments in 1990. This introduced the Acid Rain Program, a cap-and-trade system that set limits on sulfur dioxide emissions and allowed companies to trade pollution credits. Canada introduced similar regulations. Between 1990 and 2018, sulfur dioxide emissions in the U.S. dropped by over 93%. Lakes slowly regained their chemistry. Forests began to rebound. It didn't grab headlines, but it was one of the most successful environmental interventions in history. The healing of the ozone layer. The ozone layer is a thin but vital shield of gas in the stratosphere that protects us from harmful ultraviolet radiation. In the 1970s, chemists Mario Molina and Sherwood Rowland published groundbreaking research showing that CFCs, chlorofluorocarbons, were rising into the atmosphere, breaking apart under UV radiation and destroying ozone molecules. Their 1974 study in Nature laid the foundation for what would become a global environmental awakening. CFCs were everywhere, used in aerosol sprays, refrigeration, and air conditioning. At first, industry lobbyists pushed back, questioning the science. But in 1985, a team of British scientists led by Joseph Farman shocked the world when they documented a giant hole in the ozone layer over Antarctica. This was no longer theoretical. It was a planetary emergency. What followed was a rare moment of swift international action. In 1987, the Montreal Protocol was signed by 46 countries, banning CFCs and other ozone-depleting substances. Over time, nearly every country in the world joined. It was the first treaty in UN history to achieve universal ratification. The results have been nothing short of extraordinary. By 2000, ozone-depleting emissions had dropped by over 90%. Satellite imagery confirmed the ozone hole was shrinking. NASA reported in 2019 that the hole was the smallest it had been since 1982. Projections now show a full recovery of the ozone layer by 2040 in most parts of the world, and by 2066 over Antarctica. This was one of the few times in history that humanity came together, listened to the science, and acted in time. The eradication of smallpox. Smallpox is often called the deadliest disease in human history. It has existed for over 3 millennia and claimed hundreds of millions of lives, more than war, famine, and natural disasters combined. Caused by the variola virus, smallpox spread through respiratory droplets and had a horrifying mortality rate of up to 30%. Survivors were often left with permanent scarring or blindness. The first breakthrough came in 1796 when Edward Jenner, an English physician, developed the first successful vaccine using cowpox to immunize against smallpox. But it wasn't until the 20th century that global eradication became a serious goal. The World Health Organization launched its eradication initiative in 1959, but logistical and financial challenges slowed progress. Everything changed in 1967 when Dr. Donald Henderson took over as the program's lead. He championed a strategy called ring vaccination, where instead of trying to vaccinate entire populations, health workers would isolate outbreaks and immunize everyone around the infected individual. This method required meticulous data collection, surveillance, and rapid response teams. The last natural case of smallpox occurred in Somalia in 1977. In 1980, after thorough verification, the World Health Assembly officially declared smallpox eradicated. It remains the only human disease ever fully eliminated. The campaign involved more than 130 countries, millions of health workers, and the distribution of over 200 million vaccine doses. It stands as one of the greatest public health achievements in human history. Plastic-eating mealworms. Plastic is cheap, durable, and everywhere, but it's also persistent. Polystyrene, a type of plastic often found in food containers and packing materials, can take centuries to degrade. By the 2010s, microplastics were showing up in everything, from deep-sea fish to Arctic ice. In 2015, a study at Stanford University, led by Dr. Wei-Min Wu, discovered that mealworms, yes, the same insects used to feed reptiles, could survive on a diet of nothing but styrofoam. The worms digested the plastic and excreted it as biodegradable waste. The key? Microbes inside the mealworm's guts that could break the long polymer chains into simpler, harmless compounds. The discovery sparked global interest. Could we scale up this biological process to deal with our plastic crisis? Research is ongoing. Scientists are trying to isolate the specific enzymes involved and engineer them for industrial-scale biodegradation. It's still early, but the implications are enormous. Nature might already have the tools to fix the mess we made. Air-powered plastic recycling. Traditional plastic recycling is problematic. It's expensive, inefficient, and results in lower quality material. That's why in 2023, when scientists at Northwestern University announced a new method that uses only air and humidity to recycle PET plastic, the scientific community took notice. Led by Dr. Omar Farha, the team developed a catalyst based on a metal organic framework, MOF, that works under mild conditions. This method doesn't require extreme heat or toxic solvents. Instead, the MOF catalyst breaks down PET into its base monomers, ethylene glycol and terephthalic acid, which can then be repolymerized into high-quality plastic. The reaction is over 90% efficient and takes just a few hours. This innovation could revolutionize the way we handle plastic waste. PET is everywhere, in water bottles, clothing fibers, food containers, and most of it doesn't get recycled. If adopted widely, this method could turn plastic from a pollution problem into a renewable resource. Ocean cleanup on a global scale. The Great Pacific Garbage Patch is a floating mass of plastic debris more than twice the size of Texas. It's one of 5 major ocean gyres collecting discarded fishing gear, microplastics, and packaging waste. In 2013, an 18-year-old Dutch inventor named Boyan Slat proposed a radical idea: use the ocean's currents to clean itself. He founded the Ocean Cleanup, a nonprofit that developed U-shaped floating barriers to collect surface plastic. After years of prototyping and setbacks, they launched their first system in 2018. It successfully captured tons of debris in the Pacific. By 2024, over 30 million kilograms of plastic had been removed from oceans and rivers. They didn't stop there. The Ocean Cleanup also introduced interceptors, solar-powered devices deployed in rivers like the Klang in Malaysia and the Cengkareng Drain in Jakarta. These devices catch plastic before it reaches the ocean, addressing the problem at its source. The organization aims to remove 90% of floating ocean plastic by 2040. While it's not a total solution, it's a powerful demonstration of how youth-led innovation, crowdfunding, and perseverance can make a global impact. When we look at these breakthroughs, from ending acid rain to erasing smallpox, they show us something powerful. Humanity can rise to the challenge. If you enjoyed this video, don't forget to like, subscribe, and share it with someone who needs a little reminder that things can get better.